This video is on arithmetic sequences. A sequence is an ordered list of numbers. Each of the numbers in the sequence is called a term, and the terms are represented by their position in the sequence. The first term is referred to as this, which we read as a subscript 1 or a sub 1. The fifth term in the sequence would be a sub 5. And a term can be referred to in general as a sub n, or the nth term in the sequence. An explicit formula describes the nth term of the sequence in terms of n. So for example, for the explicit formula a sub n equals 3n squared, the fifth term in the sequence, or a sub 5, would take 5 and substitute it into the explicit formula for n. So 3 times 5 squared, or 3 times 25, which is equal to 75. Let's take a look at an example. A sequence has an explicit formula a sub n equals n squared minus 10. What is a sub 8? So that would be n is equal to 8. So a sub 8 would equal 8 squared minus 10, or 64 minus 10, or 54. So the eighth term in that sequence would be 54. An arithmetic sequence is a sequence in which the difference between consecutive terms is constant. This difference is called the common difference. Let me say a few things before I go on to the explicit formula here. Notice that I'm saying the word arithmetic, not arithmetic. When we say it as arithmetic, we're referring to a noun. Arithmetic is an adjective that describes the type of sequence this is. Also notice that we're talking about the difference between consecutive terms being constant. In other words, what is it that I'm adding to the first term to get the second term, and then I add the same thing to the second term to get the third term. This makes this sequence linear because the rate of change is going to be constant. So an arithmetic sequence is basically linear. As we'll see when we look at the equation, it's going to look like the equation of a line. So to find the nth term of an arithmetic sequence, we use the explicit formula a sub n equals a sub 1 plus the quantity n minus 1 times d, where a sub n is the nth term of the sequence, a sub 1 is the first term, n is the number of the term, and d is the common difference. So let's take a look at some examples here. First, we need to determine whether the sequence 97, 86, 75, 64, and so on is arithmetic. If so, state the common difference. So in other words, as I go from one number to the next, am I always adding the same amount? Well, to figure that out, I'm going to subtract backwards. So 86 minus 97 is negative 11. 75 minus 86 is negative 11, and 64 minus 75 is negative 11. So that difference is always going to be the same. So notice that that's what I need to add each time. So I need to add a negative 11 to go to the next term. So yes, this is arithmetic. And my common difference is going to be negative 11. Now again, this is a little confusing. We talk about it as a common difference, which implies subtraction, which is how you find what it is. You take the second term and subtract the first term, but basically what do I have to add to go from one term to the next term is my common difference. Here's a couple more examples. We need to write an explicit formula for each arithmetic sequence. So recall that the explicit formula is a sub n, which is equal to a sub 1 plus the quantity n minus 1 times d. So n is going to be my variable. That's going to stay as n. So I need to know what a sub 1 is and what d is. So obviously here my first term is going to be 67. My common difference is what I need to add as I go from one term to the next. And this one's rather easy to see. I can see that my common difference is 3 because each time I add 3. So my formula is going to be a sub n equals 67 plus n minus 1 times 3. And I can actually clean this up a little bit by distributing and combining like terms. So a sub n equals 67 plus 3n minus 3, or a sub n equals 3n plus 64. And as I said, because we're looking for a common difference, because we're adding the same number each time, this is going to be a linear, basically a linear relationship, and you can see it looks a lot like y equals mx plus b, which is indeed what it is. Okay. Second example here, we're told that a sub 4 is equal to negative 5 and d is equal to negative 3, but I don't know what a sub 1 is. But I can figure out what a sub 1 is by using the formula. So when a sub 4 is negative 5, that means that n is 4. So I can do a sub n, or a sub 4, which is negative 5, equals a sub 1, which is what I'm looking for, plus n minus 1 times d. Notice also I like to put my d in parentheses just so that I know that I'm going to be multiplying by a negative 3 and not just subtracting 3. So negative 5 equals a sub 1 plus 3 times negative 3. And adding 9 to each side, a sub 1 is equal to 4. Now I can write my equation, my formula, a sub n equals a sub 1 plus n minus 1 times d, and distributing. So a sub n is equal to negative 3n plus 7. Now why would we want to have an explicit formula? Well, notice that it has the variable n, so if I have an explicit formula, I can use it to find any particular term in the sequence. So for example, if I wanted to find what was the 100th term in this sequence, I would just plug in 100 for n. And that's what we need to do in the next couple examples here. So write an explicit formula and then use that formula to find the indicated term for each sequence. So I need to find a sub 32, or the 32nd term in this sequence here, for which a sub 1 is equal to 9, d is equal to, it appears to be negative 5, so I'm subtracting 5 or adding a negative 5 each time. So let's go ahead and write the formula. A sub n equals a sub 1 plus n minus 1 times d. Or a sub n is equal to negative 5n plus 14. So there's my formula, and now I'm going to use that formula to find a sub 32, or the 32nd term in this sequence. So negative 5 times 32 plus 14, so a sub 32 is equal to negative 146. Let's try another example like this, where I have a sub 1 and d, and I need to find the 17th term. So a sub n is equal to a sub 1 plus n minus 1 times d, or negative 57 plus 5n minus 5, or a sub n is equal to 5n minus 62. There's my explicit formula. And then finding the 17th term, I plug in 17 for n. So a sub 17 is equal to 23. And the last thing we're going to talk about here is arithmetic mean, or the average of two numbers. As you probably know, is the two numbers added together and divided by 2. In an arithmetic sequence, the middle term of any three consecutive terms is the arithmetic mean, or the average of the other two terms. So for example, here I have this sequence 14, and I'm missing the middle term, and then I have my third term, which is 28. In order to find that middle missing term, that's actually going to be the arithmetic mean, or the average of those two terms. So to find my missing term, I'm going to do 14 plus 28 divided by 2, which gives me 21. So my missing term in this arithmetic sequence is 21. So in this video we took a look at arithmetic sequences, how to write the explicit formula for one, and then how to use that to find the nth term of a particular sequence. We also talked about the fact that arithmetic sequences are linear because there is a common difference, the same number being added to each consecutive term in the sequence.